Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. In this video tutorial, we will discuss a problem on elastic collision of a neutron with two different nuclei taken from JEE Main exam. The question is as follows. It is found that if a neutron suffers an elastic collision with deuterium at rest, the fractional loss of its energy is Pd, while for its similar collision with carbon nucleus at rest, fractional loss of its energy is Pc. The values of Pd and Pc are respectively. The options are 0, 0, 0, 1, 0.28, 0.89 and 0.89, 0.28. Before proceeding to solve the problem, let us recall the related concepts. In case of elastic collision of two particles of masses m1 and m2 moving along the same straight line with speeds u1 and u2, their final velocities after collision are given in equations 1 and 2. In the question, we are required to find the fractional loss of energy of the neutron. Hence, we will use equation 1. Again, since the neutron undergoes elastic collision with nuclei at rest, we have u2 is equal to 0. Therefore, putting u2 is equal to 0 in equation 1, we get the final velocity of the neutron, which is given in equation 3. Now we can solve the problem in the question using these concepts. First, let us consider the elastic collision of the neutron with deuterium at rest. Since mass of the neutron is 1 unit and that of the deuterium is 2 units, we have m1 is equal to 1 and m2 is equal to 2. Again, since u2 is equal to 0, let us put u1 is equal to u. Putting these values in equation 3, we get the final velocity of the neutron, which is given by v1 is equal to minus u by 3. Now, initial kinetic energy of the neutron is E1 is equal to half m1 u square, which is equal to half u square. And final kinetic energy E1 dash is equal to half m1 v1 square, which is equal to half into u square by 9. Therefore, fractional loss of kinetic energy of the neutron is equal to 8 by 9, which is nearly equal to 0.89. Now, consider the collision of neutron with carbon nucleus at rest. For this, m1 is equal to 1 and m2 is equal to 12. Now, u1 is equal to u. Therefore, putting these values in equation 3, we get v1 is equal to minus 11u divided by 13. Now, initial kinetic energy of the neutron is E1 is equal to half u square and final Ke of the neutron is E1 dash is equal to half v1 square, which is equal to half into 121 u square divided by 169. Therefore, fractional loss of kinetic energy of the neutron is equal to 48 divided by 169, which is nearly equal to 0.28. Therefore, the values of PD and PC are 0.89 and 0.28 respectively. Therefore, the correct option is D, which completes the answer to the question. Thanks for watching. If the video is helpful, then please like and subscribe.